The Pythagorean Theorem. The Pythagorean Theorem should be very familiar to you already, but we're going to work through it carefully to talk a little bit about the terminology around triangles and as a refresher, because the Pythagorean Theorem is going to turn out to be very important to the study of trigonometry. First of all, remember that the Pythagorean Theorem only holds for a right triangle, a triangle that has a right angle somewhere in it. For convenience, we will be in the habit of naming that right angle as point C, and then the other two corners of the triangle as points A and B in either order. The side of the triangle which is furthest away from the right angle is called the hypotenuse of the triangle, and because it's the side that is opposite of angle C, we're going to call that side little c. The two sides that are near the right angle are called the legs. There's no real way of differentiating which leg is which, except one of them is the leg that is opposite angle A, so we'll call that side little a, and the other one is the side opposite angle B, so we'll call that side little b. And then together we get that a squared plus b squared equals c squared. As a quick example, let's take a look at this triangle, which has sides of length 9 and 11, and a third side unknown that we will call x. This is rotated compared to the standard right triangle we were looking at, but the first thing to do is look at x, recognize that it is near the right angle, so that's one of the legs, and that tells us that we're going to set this equation up as x squared plus the other leg, which is 9 squared, equals the hypotenuse, which is 11 squared. All right, solving that equation, 9 squared is 81, 11 squared is 121. 121 minus 81 is 40, which means that x is the square root of 40. We don't have to worry about plus or minus here because we know that x is the length of a side of a triangle, and negative side lengths don't make sense, or at least not yet. We'll talk about what a negative side length might mean in the next unit. But we can't leave our answer as the square root of 40. We have to do something. I might ask for an exact solution, in which case I'll take the square root of 40 and write that as the square root of 4 times the square root of 10, because 4 times 10 is 40, and square root of 4 is a value we can calculate. The square root of 4 is 2. So we can simplify that root and call it 2 square roots of 10. We also might want an approximate value. Exact values I like to describe as the kinds of numbers that only a mathematician can love. Approximate value, grab out your calculator and see what it has to say. In this case, it's a number that starts 6.32. Pay attention to instructions as you are solving problems. Some problems will ask for exact values. Some problems will ask for decimal approximations. If it doesn't instruct you otherwise, assume that the exact value is what you want. If it wants an approximation, usually you'll see instructions like round to the nearest tenth or round to 3 decimal places or something like that.